Okay, it's been a little while since I've made a video. I've been under the weather, but I have been working on things. Okay, in today's episode I'm going to go over some minor changes to the code that I've done. And I've added a couple of moves. Now we have the sweep kick and the flying side kick added. So I can show that. And you can see the damage is inflicted. I thought this song really sounded kind of bad, but then my son, when he was watching me program this, I heard him humming it for like some of the day afterwards. He was humming the song. So okay, so most of the characters have their sweep kicks and flying side kicks. They all have it, but not all of them have the missile sprites to go along with it. So Mai has her flying side kick. Let's see if I can get that to work here real quick. There we go. She uses letter keys, so it's a little harder to get this going. Here we go. Now she's doing her flying side kick animation. There's one. The same thing here with the. And it looks like her eye needs adjusted slightly in graphics. But where her leg pops out there at the bottom, I'll be adding a missile to extend beyond that for the kick. Just like with all the other attacks, that her arm and fist are a missile. Here her leg and foot are missiles. They're just kind of carefully overlapped to add the extra graphics. Okay, so the adventure I had here in coding, I ended up with some pretty bad jitters, and because I've been testing it on real TV, real hardware, and so yeah, some problems arose, and I'm sure that a couple of things were involved here. Some of it was redundant code, where you're basically you're doing too much in a row. Where it doesn't need to be done, and some of it was just pushing the system. For instance, I'll explain this in the code here. Okay, so we're back on the screen. I'm going to back out so it can get all blurry and crazy. Okay, now what's been changed, if anyone's been keeping up with this, I've changed around how things go. Some of this is missile definitions. Now here. Now this might be changed back later, but to lighten some of the burden on the overall speed of dealing with it. Now, just to put it into perspective, I'm getting kind of jumbling back and forth here with this, but when you look at this row of code here, you're seeing where the row is scanned over, and then what it was before was only D1 through D6, which would be the top row. So if we can see here on the screen, let's see here, about here, this top portion, and it would just automatically go. So what I've done is all of the moves that will use the missile extensions for moves, and some of the characters use missile extensions for graphics. Like I said, I'm under the weather. My son brought home something, of course I got it, and I have breathing problems. I take medicine every day for breathing, and when I get sick it hits me pretty hard. Anyway, so to take the burden off of every loop, as it's scanning through, it has to say, you know, it has to meet these criteria. Now, because with the second player, the right side character, variable 20 is 0 if no fighting moves are being done, or it is greater than 0 if a fighting move is being done. I separated all of the sprites for each character into under a second label, and that was their moves. And so now all their fighting moves are in a second, under a second label. And what this does is it lets the system take less time scanning over everything to determine if the criteria are met to end up reaching that draw screen, because it was taking way too long for it to go through every possibility in the criteria and check it, and then go to the where the label is that's containing the sprite data, and then go over every sprite pattern that was possible and to check that. So that was causing some jittering and some slowdown. Another thing I changed was in I'll try to find it real quick. Okay, here we go. The reflections. Each row of data moving to, from one point to another for the characters had a reflection point in it. But to make that more streamlined, I just moved the reflection points to the beginning of each of the background data instances here. So down here, and I think I'm getting maybe a little blurry, I don't know. Down here at the bottom we have where this was corrected in code, this row in background 1. And so this, and also in background 2, the same thing exists. Now, why I have to have that variable go along with reflections, which in this case is H. It can be whatever you want. For me, H just seemed okay. Horizontal, H, horizontal, and then the reflection on the horizontal plane kind of helped me to remember. Anyway, is so that things that aren't being reflected by those statements can also respond. So I don't have a way to say, hey, missile reflect, because the missile is defined. It has its own properties. It has height and width, and the width is actually controlled by another one of the statements. So, so to have this work properly, I need that variable there. That way, if the reflection has already been determined, then the variable will be able to determine the other parts. And that really pertains mostly to missile placement. It is primarily for missile placement. So again, I've explained this in other episodes though. When the 8-pixel wide character is doing an attack move, then a missile is put up at a certain width, at a certain height. Because I'm using 2 planes of color for each character that are overlapping to create the 3 colored sprites, I can only have 8 pixels wide, unless I want to use zooming, which I'm not going to do that because it doubles the pixel width or quadruples the pixel width. The characters would look too chunky, and I talked about this long ago in one of the first, this is something like the, I don't know, 13th episode about this. So if anybody's followed, this has become a relatively long series leading up to the final, touches of this game. So the missile is then put in place, and because there are those 2 colors that can overlap and create a 3rd color, I also have that effect with the missiles. That's how with I have the leg popping out, but I also have the sock color, and then I have the shoe color. What's happening there is a 8-pixel wide missile is put there for the leg, and it's put at the time when the body color is the color for the sprite, and then a taller but thinner sprite to be the foot. Excuse me. A taller but thinner sprite is put there for the foot, and then it's brought back slightly so that there's an overlap point, and then the overlap point creates the brighter color that's kind of like a sock. And that effect is happening with all the punches and all the kicks, unless I'm only using a solid color. And I'll probably end up A lot of the final touches of the game are going to be tweaking the missiles to get the right colors so they don't look just like a block of color that's just popping out. And you know, because you don't have as much detail with that. If I could just go in and fine tune and draw every little missile here and there, well, first off, that would give a person much more graphics capabilities. It would make it so that your missile sprites could actually just be sprites. Like, for instance, if you were making Galaga and you could define the missile, then you could layer them and define them and make them be the shape of an alien ship. And immediately you would have however many missiles you could come up with on the screen. And those could then be sprites. That'd be great. Either way, that's not the point. The point is, I'm layering them to get 3 colors, and so that's how I'm getting extra colors when the character punches or kicks. It's the same thing that's happening with the sprites themselves. So this was changed, where the reflections took place. In the original code, the reflections happened too many times, and it became somewhat redundant. It was happening too much. Later on, more of this this code will be refined. I'll be going in here, and wherever anything appears to be redundant, it will be reduced. Okay, so another place where the code was definitely redundant was in the graphics 1 and 2 areas to go out for the character's moves. Let's see if I can find a backup. This is why it helps to have backups of everything. When you have lots and lots of backups, then you can look back on the code that you made and see where adjustments were made. It really helps. Here we go. This is great right here. Now, before, A block used up, look, all of this space here. So if you look on the right side of the screen, you can see A block 2. I'll actually go up to the actual to the real comparative area here. Here we go. I know that's hair. Okay, we're gonna go way up here to where there we go. A block. Now here we have A block. This is the new A block, and you can see this is an example of refining your code. Before, A block had 4 separate instances that corresponded to each sprite that it was going out to. Now there are only 2 different sprites, but because there are 4 draw screens happening here, which I've actually reduced to 2 draw screens, which has helped streamline everything. That's another refined code. So what I've done here is where it says A block, it's actually got an instance for 0. 0 is C0, which is no character. Let's see if I can get up here. Right here in C0, this is saying, oh, you haven't picked a character yet, the title screen is going. And that's actually just going through a cycle where no sprites are put up on the screen, the title screen is happening, it's animating, and music is playing. So that's the very beginning of the game. So it's allowed to just bypass all of that hunting for sprite graphics. Now, when C is 1, though, meaning you have at least 1 character, you've begun cycling through characters to choose through a story mode or through a versus mode, then it drops down into graphics 1. Now, because A and C block, if you look on the right, you can see here, I'll go ahead and just show them here. Let's see. Here is A block originally, and then here is C block originally. They're both the same. This is redundant code. It's unnecessarily repeating because I'm using the same exact data in each one of these. So why would I do that? So instead, because a variable that's deciding what draw screen is currently being used, which is A1 goes to the first draw screen, then it becomes A2, and then A3, and so on. I know that the first call out for the sprites is A, the second call out for the first sprite is C. The first call out for the second group of sprites is B, and the second call out for the second group of sprites is D. And so I only need one chunk of data calling out for each of those sprites. So what I've got now is A and C are both above that first chunk. And so A is meeting that criteria, and then it's going to graphics 1, and then down here where it's going to hunt for those graphics, and it's exactly the same as C. So because over here A is the same as C, I only need one chunk of this graphics. So so I only need this portion right here. Okay, I don't need to copy it down here. But instead what I've done is separated them with a label that's saying go to graphics 1. Graphics 1 is that label. So it meets A block, which is the very first place it goes in the game after it has reset all the variables and everything at the very beginning. It goes straight to A block. From A block it says, hey, this is the title screen. There's no character on the screen. C is 0. That means you haven't pushed any buttons or chosen any characters. It's got the cycle counting for the animation of the title screen. Then you can see it says player 0 is X, player 0X is X, or player 0X is 0, player 0Y is 0, missile 0X is 0, missile 0Y is also 0. Then it goes to A block 2. In A block 2, it does the same exact thing, only with D, which is the variable that's telling you which second player, or the, player 1 sprite, but because it's player 1, the first player is actually going to be player 0 sprite. Anyway, as confusing as that might be. So it meets that criteria, but hey, C is 1 because you've hit the button and you're going to choose a character. So now it's going to go here and then jump down to this area to choose its graphics. So if it's done and it's gone to C block, meaning it's done with B block to get this first group of the second graphics, then it's going to go straight down to graphics. Now, C block doesn't need a go to graphics statement. Because it's automatically just going to go down to graphics 1. There are no go to statements from C block unless the C equals 0 is defined. So if C equals 0, then yes, there's a go to at the end of that statement right here. Go to A block 2, where it's going to check for D. But if that C is 1, which means you just hit a button to start looking through players, then it's dropping down to the graphics, which is down here. So again, this is getting rid of redundant code. I don't need to have all of these blocks here and here. This is all too much. I only really need this one and this one. And so that's been refined. So over here in code, the same thing has been done with each of them. It's done with A block and D block, A block, B block, C block, and D block, but also A block 2, A block, or B block 2, C block 2, and D block 2, all corresponding to the player 0 sprites, first and second layers, and the player 1 sprites, first and second layers. Another thing that was redundant, and we can look back at too, is that player 0x and player 0y are defined in every statement. Now, when I first started coding the game, it might have been necessary that I excuse me. Excuse me. When I first started coding the game, it might have been necessary that I put that in there. But because now I have a huge, circuit going on here and everything's looping around and collecting up data, I've got the patterns preparing and being ready to be displayed. I only need to say that once. So if we'll look at the code over here, you can see if every single row here within this little portion of the loop is saying the same thing, which it is here, it's saying player 0x, player 0y, and it's saying it every single time. That's just eating up space. And so if we look on the other side of the screen, right about here, we're going to see that it says player 0x equals variable 4, player 0y equals variable 5. It only says it one time. because that's going to apply to everything afterwards. This frees up space, it eliminates redundant code. The system, when checking over each line before seeing if it meets the criteria to be put in onto the stack, it doesn't take as long, because it's already decided that player 0x equals variable 4 and player 0y equals variable 5. Now that part has been decided no matter what. Then as it's searching through, the only criteria that it has to meet is the C variable in this case and variable 19. Now if I want to, and if I find out that it doesn't cause jittering or jumping or skipping or you know, if it doesn't exceed the cycle count, then I can go ahead and eliminate that second row of C1 through 6 that applies to the moves. I can put the sprites for the moves back into the label. But really, it's just going to take more time, because before it reaches the go-to that's going to return that data back to where the draw screen is, it has to look through each of those definitions for every sprite. So it's looking and saying, oh, does it meet this? No, it doesn't. Okay, I'm skipping to the next one. Does it meet this one? No, it doesn't. And so when it grabs at your first sprite, it's looking and it goes, oh, it meets this one. Then it gets the sprite data. But then it goes to the next one and goes, wait a minute, it meets this one. Then it changes to that. That just wasted time. And if it has to do that through a row of 10 sprites, that's just taking a really long time for it to dig through all that. If I cut them in half, and then the more you strictly define each sprite, well, then you just sped up the process. And if you want to really speed up the process and nerd out here, the most changing variable should be first. So in the case here, variable C, it might actually be smarter in this case to switch variable C with variable 19, because as you're playing the game, variable 19 is going to be changing constantly, whereas C is not going to be changing. And then this might be a way to get even further through this, to make even now what I'd have to do then to make less code is to make a second label that's past this, maybe graphics 2A, graphics 2B, and I probably won't do this, but this is something I might be able to do if I find that this is something that needs to be done. And then the channels for each of those labels would go along with variable 19 itself. But you're really getting into the point where the time it takes to be told to go to another label might actually exceed the time that it takes to run through each of those labels and check them, because none of them are go-to statements until they meet the criteria of those first two variables. So just checking those first two variables, that's not going to take very long. And once it does check one, in this case especially, in the graphics, it has a go-to. So that immediately jumps it out of there back to where it needs to go, and it has the data prepared. So again, this is a situation, as you can see, where when you're first making code, there are certain things you need to do. I needed to have my variables put in place. Perhaps I only had one sprite, but I didn't know what order the sprites were going to go into before I put them up on the screen, or who was going to be where. And so I made sure to keep the variables that controlled the XY coordinates of the sprites in order with them. And then eventually, as I added characters, I just copied and pasted and then changed the colors that went along with each of the characters. But because I knew that the XY coordinates needed to be the same, those were part of that same strip of code. But then after everything's already been established and that loop has already been created, and I already know which character is starting where and what XY coordinate they're going to have, and that they're all tied together to those two variables, now I only need to declare those two variables once. So you can see, and this frees up a considerable amount of space because, you know, there's much less code, but then also it speeds up the process because it doesn't have to add that part. That part has already been established at the beginning before it cycles through each of those possibilities. So more changes that have been made. The draw screen, as it was going along with each of cycling through the background data before getting to the next go-to statement, I wanted to see if I could speed that up. And so it dawned on me that after it collects the data for controls and for screens and sprites and everything, then it loops back around, and then at the end of the loop, which of course is the beginning of the next loop, that might be the best place for the draw screen. And it also corresponds with the go sub. So where the go sub that's going to take the most amount of time on the system, which is for changing music notes, has already collected the data and assigned the colors for the backgrounds and has completed its little circuit, then it's drawing the screen. Now, with certain kernels, that's not going to be feasible because your background definition has to be within the loop that the draw screen is in. But because this is the standard kernel super chip, I don't have to worry about that. It's gathering up the data in the loop externally and then arriving at where the color definitions for everything is. Now the color definitions are big changers. They're really, those are what's changing, you know, the entire screen, the luminescence and everything. So it's very important. Some of the heaviest occurrences are in each of these strips of data. So having them separate might have been helping to bog down the system, and then having the draw screen right after every one of those things is defined has lightened that burden, so to speak. So hopefully this will work. Like I said, I've added punches, or I've added flying side kicks and sweep kicks. Everybody's got it now. I've changed some of the data around. I've gotten rid of some redundant code. This is all happening quickly. I've been, like I said, I got sick like twice within the past couple of months, and that's kind of slowing me down a little bit. And I've also started a little second project with my son where, and this is completely unrelated to this, but we found out, I was talking to him about Lego Creator, and we found out that Lego Creator actually works on Windows 10 because it, believe it or not, it doesn't work, at least the first version of it doesn't work on Windows 2000. So, excuse me. So, I went ahead and put that on his laptop, and I put it on my laptop, and we began making Lego model kits with Lego Creator. This was a program that came out in 2000. So it's 24 years old. I remember buying it in the store, you know, back when you went to stores and bought things off the shelf. And I remember seeing it, and I've always been just a, you know, completely loopy about building blocks. I love Mega Blocks and Lego, and all these, you know, Temu Lego kits have really been reigniting my fire for building. What I did back in the day was I made stop motion animation with Legos, and I still have it. I haven't put my final work, you know, up on YouTube, but I have like a, whatever, like a 15-minute long video with a transforming warplane made of Legos. And the model kit, actually, the model stands up and has moving arms, and it has a little cockpit for the pilot, and I built 3 transforming warplane Lego kits from scratch. My oldest son copied one and made his own once, and it was just a, you know, made my head bigger, made my head swell, because he took my design and he copied it completely. And I loved it. It was just a, you know, labor of love for a couple of years there doing Lego stop motion. And so my youngest son does Lego stop motion now in his room. and we were talking about the Lego programs, and I said, well, you know, I think the best Lego video game program ever is Lego Creator. And so I still have the disc, but then I was looking up data and found out that Lego Creator actually works on Windows 10, and we both have Windows 10 on our laptops, so I put it on both of our laptops so that we could play that. And I started building the Starship Enterprise out of Legos in Lego Creator. And that's been something where when I was sick and I guess I couldn't really focus so hard on coding, I started building this giant starship. So I like how this is looking. Everything seems to be working well. I need to try some of the heavier stuff here. This guy, okay, so here we're seeing there's Guile's kick, punch. There's his sweep kick. There's his side kick. Okay, we've got this guy's flying side kick, sweep kick, his punch, his kick. Now I'm trying to see if I can get a visible jitter within the emulator. And just because something doesn't hop or skip or jitter in your emulator, I've probably said this before, does not mean, looks like their collisions didn't work there for a moment. That's something I'll have to look into. Does not mean that it won't do it on hardware. So when you check this stuff out, when you're making these games, something you really don't want to do is do huge leaps and bounds in your coding and not check it on a real TV, because you're going to run into problems. Just because it seems to look right and it doesn't skip or jitter or hop or flicker or whatever on your Stella emulator or your computer emulator does not mean that that's going to not happen on real hardware on a real TV. So you want to make absolutely sure that you check the stuff on real hardware. It's very important. And that's something I've been doing, and the last big change in code that I did actually did produce a whole bunch of jittering and skipping and hopping and stuff. And so I had to go in and hunt down redundant code and get rid of it. I had to change things around. Now I'm testing everything on this helicopter background because it has the ever-changing helicopter blade thing. I figure if it's going to skip and hop and jump, it's going to on this one because of all that extra stuff happening on the background. So we can see here's hers. Now I might be changing this. This is just a purple block, and I'd like her to have kind of a little heel to her boot. But I don't know, I might be asking too much for that. And Mai's blade for her sweep kick and kick, as I said, isn't done yet, but her kick and punch are there. She's going to have more moves. Kind of hard to play both characters at once. And their collisions are not working properly sometimes. And I know why. It's because the draw screens are after the collisions have been defined, and so I need to find a place in the loop where it's a better place to look for collisions before draw screen. It might be in that original first part of the loop before the draw screen. Either way, that's not heavy code. It's 2 lines to check originally for collisions, and the collisions work well. Plus putting it up in the first row might help, because the way this game works to keep everything the way it is, it's actually only grabbing data for movement of the characters and the speed of their movement and stuff one time within each of those graphics grabs. So when it's reaching out for graphics, it's not checking every single time. But if I put the collision detection in those first 2 loops, then it will be checking for collision all 4 draw screens. And well, actually it's been reduced to 2 draw screens by doing this, which cuts back on it a lot. It helps a lot to do that. I'm not really, you know, moving, thinking perfect. I'm on medicine and coughing my brains out and stuff like that, and I've just gotten to where in the past couple of days I'm kind of got enough energy and ready to code and kind of do it again. So I got the Sidekick code done, and I reorganized things a little bit to try to speed things up and get rid of jitters and stuff, and then tested on real hardware, found out I'd actually created more jitters and hopping and stuff. And that's one thing that's very frustrating, is when you're using an emulator and the emulator doesn't exhibit that, and then you have to test real hardware. So I have to, you know, get an SD card, I have to move the data onto the SD card, I got to take it to a multi-cart, I have to have the TV warmed up, the CRT, I have to have what systems I'm testing and stuff, everything's got to be ready, and then I'm checking, and then I have to do all of those processes with controllers to check it on a real TV. It's actually a little easier to test just using a keyboard because my fingers are close together when I'm on the keyboard here. When I'm trying to test with joysticks, you know, I'm having to hold two game pads or 2 joysticks and move them around and try to hit buttons at the same time. Obviously that's a little more difficult. But it's not that, it's so difficult to where I can't trigger whatever, you know, jitters were happening before. So anyway, getting rid of redundant code or changing code so that things are sped up and not as many cycles are used. So now we have 2 draw screens instead of 4. We have the majority of the heavy cycle stuff consolidated. We have music as part of the draw screen loop, so the go sub for the music is right there with it, because with the draw screen being somewhere else, once this go sub happens, that's a heavier chunk of data that's waiting to be put up on the screen with the draw screen. The draw screen is essentially everything you've accumulated is now happening. Okay, so when that happens, all of this stuff that's been sorted through, and so these not collision statements might not be needed. These were done in the beginning to try to help out with code, and so with these collision statements, if I have these in the first loop, which I have not much code left in, but probably enough for this, and there isn't any need for too much more. Really just these players collide is really the most important one, because that's going to keep them from just passing through each other when they're jumping and moving and stuff. The ones that have to do with the attacks are they're less intensive because the attacks excuse me, are happening right there in front of each other. So yeah, things are going to be moved around. I was going to move around a lot of code, but this video is already longer than I wanted it to be. This is just kind of an update on what's been going on. The 2600 Plus I think is going to be out very soon if it's not out already. I'm hoping that it's a good system that's going to support these cartridges, the higher kilobyte cartridges. Excuse me. I'm not entirely sure that my cartridge is going to work on a 2600 Plus. I've said this before, but I'm actually kind of a little bit concerned that it's going to be a picky system that only supports whatever 8K or 16K at the most. But like the flashback portable systems, those were really picky. The flashback systems weren't very picky. They would support pretty much every game. I don't think I ever had any game that wouldn't work on a flashback, even though I used eccentric methods to get the stuff happening. Now, on that note though, flashback systems aren't very good for certain types of homebrew. and my homebrew especially, because I use layered graphics, flashback systems seem to lose sync every once in a while with layered graphics. And this actually happens with other homebrewers games. For instance, the really intense, beautiful version of Donkey Kong where it scrolls up and it has multicolored sprites and it looks like Nintendo art and stuff like that. That game, on a flashback console through a TV, HDMI or video out or whatever, will every once in a while have just kind of like a flicker, just one solid blink, kind of blink, like your game will be going, oh, it looks good, blink, then it's going, it looks really good, blink. And it doesn't happen a lot, but it does happen. What that is the emulator cannot keep a consistent 60 frames per second cycle going on. It can't do that. It can't refresh perfectly. Now on my computer, not only can it do that, but it can keep it perfect. So my computer is running Stella with that perfectly. The effect I'm talking about will never happen on a CRT, because the CRT is running that perfect amount. It's never going to happen. And on a television, depending on the type of television, it might happen on a high definition TV. It depends on how, there's so many different ways that those can create the image on the screen. If it's processing something and you have some type of frame lag going on where it can't meet or continually create 60 frames per second, then you can see problems. And that can happen with excuse me. Good. That's funny. I haven't coughed like this in a couple of days, and I thought I'm going to go ahead and make this video, and now I'm sitting here making this video and I'm coughing more than I have in a couple of days. So, if you buy a homebrew game, and a lot of homebrew games are like this, and you're playing them on a flashback console, you might see a little flicker. I might actually show it later. I might do a video later of my game on all of the different things that it could be seen through. I think that'd be a good idea to show people. First off, you'd see a massive difference in colors. Like I'll show 3 or 4 different Atari systems through the same television, and you'll see several different types of colors and clarity and everything going on. Also with flashback systems, you'll see that the flashback systems every once in a while will have a little hiccup that happens as it can't keep up with that frame rate. So ideally, real hardware, CRT, something that can produce, that's strong enough to reproduce 60 frames a second. So if you're playing it on Stella, it's going to be perfect, because Stella is actually better than the real hardware. It's not going to blur or flicker or hop or skip unless the cycle count's really being stressed. But a flashback is not that powerful. And so a flashback system, I tested it on Flashback 9, Flashback 2, and Flashback portables. And games, most of my games that are 32K super chip won't even work on a flashback portable. Actually, what's really funny though is Titanax, the game I had published, is 32K, and it does work on a flashback portable. It actually works very, very well and looks really good. But these games, results are going to vary based on how you're producing this game up on the screen. And I would hate someone to buy my game and go, oh, I'm playing this on my flashback or whatever. Well, you couldn't play it on a flashback unless it had a cartridge port, because I don't plan on giving out a ROM for this game. And it's one of those situations where, just like with Titanax, if my actual real copyright owned game is out there in the wild as a ROM, that's illegal, because I have never given my video game away as a ROM. The only way for the actual commercial release of Titanax to be played is on a cartridge, and illegally, because I've never given permission for my game to be copied. But these ROM dumping, of course someone could dump it, and probably has, and once they dumped it, they now have an illegal copy of my game. And if it gets out on websites and people are passing around giving it out, Now there are demos that I've given out, but those are not the complete game and they don't play properly. They're too fast and the interactions aren't fine-tuned, so they're not going to work right. But that game does work on the Flashback Portable, and certain things can be done to make games work, but the games where layered graphics are happening, especially like with that souped up Donkey Kong game and with all the games that I make now, there's going to be a hiccup every once in a while on those low-end emulation systems. And I'm hoping that the 2600 Plus is just a touch above those other ones, that maybe perhaps it's a faster processor or it's just a higher quality emulation where you're going to get a consistent 60 frames a second per game. Then my games are going to look really, really great. So anyway, thanks to everybody who's following, checking up with me. I had 69 views on my last video. That's really, really great. I had over 100 views on the one before that. And so thank you very much, whoever's keeping up. Sorry I'm coughing my brains out during this video. And keep up.